Yeah, so good morning, everyone. Yes, thank you. Before understanding today's concepts, let's try to recollect it what we had it in the last section, and then we'll continue. Yeah, so we were understanding that's the one of the important concept about the client and server architecture. Yes, that's why we started this one is, yes, if you'd like to understand exact the usage of the networking and why we are good, why do we need that networks and all these systems, the whatever the Linux commands or Linux concepts which we are understanding of that virtual machine point of view. Yes, the usage, if you like to understand it, yeah, we should know the high availability architecture, how the production environments, and as well as how the request and response flows that we'll be having, and what is the architecture that they follow that while designing their applications. Yes, there are some terminologies and as well as some important the resources which are required to host the application. So that's we are trying to understand it. Yes, that's about client and server architecture and as well as high availability architecture. These are the 2 points. And we were starting this client and server architecture. In that client and server architecture, there were yes, like a backend, the server's IP address, and then service, and service contains that application, and with that its ports. And once that's the machine and with the service and applications are available, how the URL will be constructed, and that URL instead of accessing this directly, how do you go ahead with the DNS name, so DNS registry, how that is supporting that. Yes, whenever we hit the URL, exactly what is happening that the background. Yes, first request will be routed to the DNS service, and DNS is going to return that server IP details. And then the TCP protocol over the network using the router concepts, it routes the request to the backend server, and within the server service. Service is that is a Tomcat or Apache or database. They're all the services which contain the port. And on the base of the port, it will be routed to the service, and service is going to running this application, so which is hosted on the server. Now there are some points on that two-tier client architecture and three-tier or n-tier client server client and server architecture which we're trying to understand it. Yes, mostly we see that the client and server architecture like three-tier or n-tier. N. Why we are talking this n-tier is, yes, the client whenever he requests that's yes, application point of view, whenever he submit any request is received to this application layer, and application layer is going to communicate to the backend layer. But backend layer, not only the databases, on the base of the messaging systems, yes, it is required to communicate with that backend SMTP services or SMS services or reporting services. Yeah, app layer is going to take care of that integration of the backend, the layers, and processing this request and giving the response back to the client. Yeah, in this request and response, what are the layers that is communicating that is processing that? All those layers we say that client and server architecture, that could be 3 layer or 4 layers or the 5 layers. Yeah, that is understanding client and server architecture, and then we are understanding application resources also. Yes, if you are hosting that any application, yes, programming language is required to implement the complete functionality. And once that's a programming application is ready, that application to host it, the server is required. But server middleware server doesn't store that application data. We need to have the backend databases for it. Yes, databases. But the databases or the middleware services or the programs to run it, yes, the OS is required. That is virtual machines, which is having that either Windows operating system or Unix operating system with its storages, networks. So these are all the components that's together. We can say that, yeah, the application hosting resources. So that contains infra resources, platform resources, and application resources. Yeah, there are the set of resources that is required to host the application. But these resources not enough just to hosting the application on the single server or single machine. We don't see that, but it requires with the high availability, failovers, load balancing, securities. So these are all some major components or major considerations whenever we are designing that application in the live environment. But what about that? The high availability architecture. In the last section, which we are understanding, client and server architecture with the application components. That is the infra layer, platform layer, and app layer. But once all these have been decided, but how do we design the high availability architecture, failovers, load balancing, security? These are all some major considerations that will be identified while designing the application in the production environment. Yeah, so that's until that, the which we had it in the last section. I hope so I remember it right. I remember that's until that. So any other points which we had it? Have we completed this high availability architecture also? Or do we need to discuss this one? Sorry. So we had up to this, right? The client and server architecture and application resources. Yeah, now let's move into that. The high availability architecture understanding. Is it clear? Those concepts. Any queries, questions, please let me know before moving to the next. Are you clear about those points? Any queries, please use the chat window quickly. Say that I'm good. Okay, good. Everyone is in silent mode. Please quickly confirm that. Then I'll go ahead. Okay, good. I would like to see the response from everyone. Until that, I don't go. Okay, good. Or if you have any queries, just let me know that. Be active, be active. Good, good. Yeah, definitely. Okay, cool. Thank you. Yeah, so let's look into that some important design considerations. So whenever we are talking about it, high availability. Yeah, high availability architecture. So this one of the important point is the high availability. As 24/7, this application must be available. And second option is the failover handling. Yes, we see that the failures. in the environment, but how you are going to take the actions on the failover and what is the time you are taking us to recover of it. Those are all the important points that would be that will be considered. And the failovers, and then load balancing. Yes, how to manage the load. The one member is accessing or 1 lakh users are accessing that. How the request and response times. So that is another important point. And securities. Yeah, all these points whenever we consider that. So now let me talk it. So this how that would be is. Suppose as we are talking that if I launch this one virtual machine, which is having some IP address 1.1, and if I set up the Tomcat or some server in it, which is on the port number 8080, and if I deploy that application, yeah, whenever we host that application with these three components, yes, that's how the URL would be. If I would like to access this application, first I need to connect it to the machine level, then port level, then application level. This is the URL. Okay, now you have hosted the application and you have the URL, and URL has been given to the client. But I mean, this way we don't give it, but just assume that. So you have given this URL to the client, boss, we have hosted the application, use this URL and access it. Okay, he has accepted and he's trying to access this application using this URL. But suddenly the server is down. The Tomcat server or WebLogic or Sphere, whatever the server you are running there, the server is down. What's going to happen to that? URL, is it going to work it? Yeah, the machine is reachable, virtual machine is reachable, but within the virtual machine, server is down, that port is not listening. Port is not listening. Port is not listening is nothing but obviously application which is running on that service also will be shut down. That means that URL who are, I mean the client who is asking about it, that URL is not going to work in that. So URL is down. But if we would like to make it a high availability, then what do we need to do? So if you just launch it, that's one server, that is not a high availability. Okay, you have come up with that. If you manage it only one server, it is not, I mean, if it is got failed, there is no availability. Let's launch it the two servers. Can we launch the two servers on the single machine? Yes, we can launch it two servers on the single machine, but with different ports. Suppose Tomcat server 1 and Tomcat server 2, two servers I have launched it with the two different ports. I'm good. But what about the URLs? URL, are you going to have it only one or multiple? So here two URL, that's we need to have it, right? Yeah, one is machine IP address is the same. Okay, 1.1. And one service, one application which is running on the service 8080, another same application which is running on 8081. Then ports are going to changing that. Ports are changed is nothing but as a number of services, number of URLs. Number of services, number of URLs. Okay, this is URL 1 and this is URL 2. But client is not going to accept it two URLs, right? Normally we don't share the two URLs. Application only one URL. And you are saying that boss, like one server, if you manage it, it is getting failed. That's why we launched the two servers. But two servers, two URLs we have. Access the first URL. If it is not working, use the second URL. Okay, for the timing, client is accepted. But this is not the solution finally. But okay, let's assume that final solution will come back. Okay, client is accepted and he is using this. The first URL 8080, or if it is not working, if the service is down, then he is going to use the second URL, that is 8081. But if the machine is itself is down, That means the IP address itself is not reachable, right? If the IP address itself is not reachable, is nothing but all these two services which you have set up, that both are down. All the server URLs are down. Then can we say this is a high availability?
Not at all.
Yeah, so this is not the high availability. So what do we need to plan it? At least two virtual machines we need to plan it. At least two virtual machines we need to plan it. And those two services, whatever we are talking, that the Tomcat 2 servers, instead of launching this on the single machine, launch it in the two different machines. Yeah, the machine 1 1.1 and machine 2 1.2. But whenever the IP addresses have been changed, then ports can be same or different, right? So the Tomcat server, whatever I'm launching here, the same Tomcat I can launch it in the second machine also. I can use the same ports because they're on the two different machines. But if the same IP address, that means same machine, port numbers must be different. So if it is the same machine, two Tomcat servers you are installing, then two different ports required. But if it's the different machines, different Tomcats on the different machine, then you can use the same port. Here 8080, yes, you can use it, and here also 8080, you can use it. Okay, good. Now we have the two machines. One machine got failed, another machine is available, or one server got failed, another server which is running in different machine. But URLs are going to change it, right? 1.1:8080/app or 1.2:8080/app. The URLs are going to change it. So now these are all the two URLs you have given with the high availability. Was one machine got failed? Yes, we have one more machine. Or one Tomcat server got failed? Yes, we have another Tomcat server which is running entirely in the different machine. So this is the design we have done. But you have the two URLs. Access the first URL. If it is not working, then use the second URL. This is a solution you have given. Okay, client is temporarily accepted. Fine. But now the point is next database point of view. So yes, the middleware or Apache service or the web services, whenever we talk it, this is the solution. That means at least multiple machines required. And in those machines, you need to set up the services. So you are increasing the machines here. These are all distributed architecture. You can manage it, web servers or the app servers on the distributed architecture. That means multiple virtual machines you can take it and you can install it and you can define that grouping together. So this is a distributed architecture. We'll come back in the cloud also, all these technologies and all these. I mean now, so this architecture, whatever we are going to talk it, whenever we are going to discuss this AWS, how do we implement all these concepts in the AWS? That is, we are going to learn it. But how the AWS has been given the solution, we'll see that. But if you are planning to host that application, there are all the points that we need to consider it. Yeah, app services or web services. That is like Apache or Nginx if you're going to use it, or like a Tomcat or WebRack if you're going to use it. We say that this is the distributed architecture. That means you can have the multiple virtual machines and you can set up the servers on the virtual machines and you can define that all these URLs with the load balancer. That's will come back. Okay, now you have defined the two virtual machines, two servers. Now we have the two URLs. One URL is the down, another URL you can use it. Fine. What about the failure here? How it is going to handle the failure here? Suppose failure in the sense. So I have submitted the request to my app server. App server is received the request. And while doing the process, suddenly this app server, because of some memory issues, some disk issues, it is got failed. Already user has submitted the request to the server. But while processing that request, that is in the middle of the transaction, the server got failed. Then normally user what is that what's going to have it, what is response is going to have it. Suddenly that is a 404 page cannot be displayed. So if you see there's a the 404, that is a page cannot be displayed, or some 5xx services status codes we have will come back. I mean some exception the backend which is happened. So the failure is happened, but the failure you should not give to that user saying about it, page cannot be displayed, or 503 bad gateway, or service not available. We should not show those kind of the messages, right? So we need to handle the transaction. So that failure should be handled. So what are the concepts that we have to say? The failures to handle the clusters concepts are available. So what the cluster, if you define this all these services within the cluster, what the cluster will do is, so while processing the request, if something is wrong in this service, that request will be handed over to that another service which is in the group. That is a group of services. That is logically grouping all the services. It is kind of the teamwork. So one member he is not working, then another member hand over the work to that another member. So cluster concepts are helping to handle the failovers. So multiple virtual machines, setting up that these services on those multiple virtual machines, and all these services logically grouping that to handle the failovers. This is a failover especially. So suppose whenever I'm accessing the URL, if this URL doesn't work it, I use the second URL. That is fine. That is availability. But you have already submitted the request and request is in the process, middle of the process, but suddenly the service got failed. How do you handle that request? It should not saying that's responding to the client, I cannot process it and please contact after some time. Yeah, we see this in the IRCTC, this kind of application. Whenever we are doing that Tatkal booking, we get it those kind of the messages. That means backend, all the services are the busy. And you have waited, and connections. Yeah, that is a handled, that failure has been handled. So connections available, okay, connect to the database and process the transaction and give the response back. If the connections are busy with the databases or backend resources, then wait some time, but still that is not available after the specific time, then give the response to the client saying that we are not able to process for the timing. Please contact later. That is also handling, fault handling. Yeah, so all these mechanisms that should be handled. And backend database. So database wise also the required 2 or more instances, or we have that like a master and standby concept. So database is a non-distributed. Actually, it comes under non-distributed architecture. Suppose virtual machines wise, we say that are a Tomcat wise, okay, 10 Tomcat servers, configure it and group it. Application to handle that. Okay, we have the concept of it. But databases point of view, 10 database instances, launch it and group it. So we have the cluster concept from that. But whenever we are moving the cloud concepts, especially, yes, we have that a master and standby concept as a primary and a secondary concept. As we say that non-distributed architecture, especially in the Kubernetes and all these, whenever we are talking that, the databases comes under non-distributed architecture. So here also we need to have that 2 or more database instances, and one should take the responsibility of that handling, and the second one has to work like as a standby. Or we have the some of the databases which are having that cluster concepts on the base of the database provider. These are all the concepts. Yeah, create the cluster, rack cluster, and that listener share it to the middleware, and then middleware can communicate to this backend database cluster. Even one database instance failed, another database instance is going to automatically handling the transactions of the database. That is a concept here at the backend level. Yeah, databases level, that is required 2 or more database instances to handle the high availability failovers. And a middleware point of view, that is required the 2 or more virtual machines with 2 or more services. And with the cluster concepts handling about it, all the request and responses. Okay, fine. You have set up thus all these scenarios to handle the high availability and the failover. But here the point, if you just talk it as a number of servers you have configured middleware point of view, number of URLs we are going to have it, right? Suppose if you launch it at the 10 Tomcat servers or 10 Apache services, we are understanding Apache, how do we install it and how do we set up that. But if we set up the 10 Apache services, then 10 URLs will be having. How the 10 URLs will be handled? So we need to go for load balancers. But load balancers, whenever we talk it, we have the two types of the load balancers. So one type like which we can say the software load balancer. We can say there are the proxy services also. Proxy servers or reverse proxy. So whatever the software load balancer is, suppose Apache, whatever we are talking that's we were using as a web server. As a web server. But I can take it thus the Apache server, which is on the port number 80 WS-1, that is a web server, Apache or Nginx or whatever it is. Yeah, we can take this virtual machine and install that Apache or a web server. And this web server, we can configure as a load balancer to the backend Tomcat servers. Tomcat or WebLike or whatever it is. Backend app servers can be routed from the web servers. But web servers by default, they're all not able to route it. We need to configure some modules or plugins. By adding these plugins, we can configure the web server as a proxy server. Now these backend, what are the app server URLs we have? These app server URLs, these two URLs, we take it and we configure this in the web server. Now the web server URL, once such web server is ready, web server URL, whatever we have, that's we can use it to access this application. Now, as per this web server configuration, 1.3 IP address, :80 is the port and application name. So this is the URL, 1.3:80/app. If you hit this URL, so client is going to hit this URL. Okay, the proxy is receiving that, this web server is receiving the request, and it is going to check it whether this app server is reachable or not, this app server is reachable or not, availability, and what is the load that is having this app server, what is the load it is having this app server. On the basis of the load, it is going to use it algorithms internally, that is round robin algorithms. It is going to route to that one of the app server. Then this app server is going to process the request, and on the basis of this request and using this database listener, it connects to that one of the database and accessing the data, and performing the transaction, giving the response back to the web server. and web server is going to return back to the client. Yeah, now instead of giving the two URLs, we have that web server URL, which is working like as a load balancer, load distribution, and as well as it is going to handling the failover also. Yes, before routing to the request to the backend services, which services are available? That means backend endpoint. So this endpoint 1.1 colon 8080, this endpoint is it available, or 1.2 colon 8080, which endpoint is available? It is going to checking that, and it is going to route to that one of the backend endpoint. All these technologies are the very important. So next, whenever we are going to talk it that AWS architectures or Kubernetes the architectures. So those are the keywords we use it: backend endpoints, front end listener. There's an entry point which routes to the backend endpoints. One endpoint is one URL. Where exactly the resource is located, that URL will say that one endpoint. Okay, so now it has been configured that reverse proxy mechanism. That means by using the web server itself, we can configure as a load balancer, routing to the backend services. But now can we say this is a high availability? Can we say this is a high availability? Now we have the two app services, the multiple database instances with the cluster concept, and a proxy service mechanism, that is software load balancer. Can we say this is a high availability? No, this is not a high availability. In case the software load balancer, whatever we have configured, so this virtual machine is down, that 1.3 machine is down, or this 80 service, Apache service is down, then backend you have the two services or 10 services or 10 endpoints, doesn't matter that all the endpoints you cannot communicate it, right? So here also we need to have the two or more proxy services. That means two virtual machines, and configuring that on these two virtual machines, two proxy servers, and mapping about these two the server URLs in this server also, and this server is one more URL. That means 1.3 colon 80 with application this service, and 1.4 colon 80 with this application this service. Two URLs we got it. One got failed, another is available. Because this is also distributed. We don't have that only one server is up and running and handling that the backend services. This is not the active and the passive. Web servers and app servers are the distributed architecture. Two or more endpoints required or entry points required. So this is also service, right? If the service is down, like systemctl status commands, we are understanding that, or stop commands, we are understanding. These are also service. Okay, now you have defined the two or more, the proxy servers, two or more middleware servers, and two or more database instances. High availability to handle it, load balancing to handle that, and failovers to handle that. Okay, you have taken that at least two machines, two services. That means endpoints. But still the problem what we have is as a number of proxy services, number of proxy URL that we have. But are you going to share it this number of URLs to the client? No. So what is another kind of the load balancer which we use? That is a hardware level load balancer. But this is only one load balancer. We don't see like as a here proxy like how you are managing the multiple. But here we'll be having only one load balancer. This is having that active and passive mechanism. That means only one endpoint, one entry point, and this entry point which will be used to access the application. But in case this load balancer is got failed, the passive one is going to become that as active. That means two load balancers will be having, but only one will be active. And active one is whenever it is down, then passive one is going to become that active. So these are all like we can say that a hardware level load balancer. That's where we have the Cisco or big IPs F5. There are some like on-premises environment solutions. On-premises environment, the solution. But cloud, how it is going to support it. Next, whenever we are going to learn the cloud, yes, all these points we look into that. Solutions from the cloud provider, virtual machines, databases, load balancers. Okay, so this is a load, this is a hardware level load balancer, which will configure it. And now these two endpoints of this load balancer will configure here. And now this load balancer URL is going to have that entry point, right? This entry point or listener, which will be configured at a DNS level. That is domain name service. That is domain name registry. Like google.com or facebook.com. So what are the domains we are talking that? Yes, for about our application, what are the domain we have? So the domain level, we will configure this load balancer URL. Yeah, the finally that application related domain name, right? Like example ornisk.com or co.in or whatever it is. So this will be configured mapping with the load balancer, and load balancer is going to have that proxy service, the endpoints, and proxy service is going to have that app server endpoints, and app server is going to have the database listener. So this is the flow of execution that will be happening. Okay, now we understand high availability, load balancing, failover. But what about the security? Why do we need this proxy layer? Directly, we can configure these apps server endpoint URLs at the load balance level, right?
Yes.
Why do we need these web servers? Why do you want to additionally that is a software load balancers? One more layer, you are increasing that in the request and response flow. With the more layers have been increased, then performance will be degraded. That is latency issues will be having. So coming to the load balancer the proxy layer to the app layer understanding the request and processing that, and communicating with the backend data layers, and then processing this data and giving back to this, to the user. But why do we need this layer is abstracting about that app layers and data layers from the external world. That is one point. And static content, if you have anything which is having for this application, yes, you can keep that in static application content here itself. You don't need to route the request to the app server if you have any static content accessing. Yes, as we're talking that web server supports static content data. Yes, static content you can manage it here, and you can abstract that. That is, you can protect the backend app layers. That means any hacker is hacking this load balancer, he can view that the backend these two endpoints only, but actual application is running in this app server layer. and as well as the networks, as we're understanding that. Yes. So these load balancers which will be in that public network, that is external network, or we say that dematerialized zone. And app services and databases we keep that in the private networks, that is internal networks. So external, no one can access this. Only through the proxy layer will allow that. And this proxy layer will allow that only through this load balancer. Yeah, to protect it from the hackers or unauthenticated users, then we need to go for that. These networks, external network and internal networks. And not only that, between one layer to another layer, we configure the firewalls, securities. Who can access this layer? Only the load balancer can access. Who can access this app layer? Only a proxy layer can access it. Who can access this layer databases? Only the app service layer can access that. So we define the databases in the separate subnet mask, app layers into the separate subnet mask, and proxy layers into the separate subnet mask. Separate network groups. That's why we're talking about it. CIDR. Yeah, in this network, how many number of IP addresses required? In this network, how many number of IP addresses required? In this network, how many number of IP addresses required? We will define that different subnets to manage that different services. The middlewares into that one separate network, databases into separate network, and the proxies into separate network. And between one network to another network entry point of view, which IP address should be allow that, which IP address should be denied that. The rules we can define it. That's a firewalls configuration. Yeah, so all these points, the security point of view, the networks. Yeah, the first if you're designing is nothing but networks required. So databases, how many databases IP addresses required? As per that, define the CADR. And middleware services, how many you are expecting today or future. Then as per that, define the CADR for it with a subnet mask. Then for this separate CADR. So entire network, and the network is dividing into small units. And that will come back in the cloud. Yeah, whatever the Linux networking concept, the CADR in the last section, whatever we are trying to understand it. Yes, on the base of the databases or the middleware components or the proxy services, we define the networks. And we define the subnets. Subnet if we are defining is nothing but how many number of IP addresses that is required. As the number of services which you are planning. Do you want to set up this 100 servers, 1,000 servers? On the base of the requirements, CADR will be decided. And whenever we are creating a network, is it a public network or the private network? That is also another important. And between the one network to another network, firewalls will be defined. Subnets level firewalls. And before entering into that EC2 instance, that's virtual machines point of view, the firewalls required. So one network to another network level, entering that firewalls will be defined. Not only that, before entering into that, the virtual machine, the firewalls required. Whether it should be allowed for this particular port or not. From which IP address the request is receiving, that IP address should be allowed entering into this virtual machine or not. That IP address should be allowed to enter into this network or not. Network level firewalls and resource level firewall. That is database or that could be a virtual machine. So all these points that is required to understand it to set up one application. Now, if you just observe that application is a small component, right? Application is a small component, but application is having its importance, fine. But in the production environment, whenever we talk it, that's application, and application is a small component, but important considerations: high availability, failover, load balancing, securities, scalability. Here I didn't talk it, still that's a scalability concept, but that is another important. What is the scalability? Suppose now we have the two middleware servers, and application is hosted and running that. In the normal, suppose riseandtechnologies.com, if you just talk it, okay, it has been hosted on the two servers and normal load is going on. But suddenly we have given some offers and the users are more. Whenever the users are the more, what about that, like the standard capacity which are defined it, the standard capacity is not sufficient for it. Suddenly the load is increased. As per the load to handle that, if you have the sufficient CPU, sufficient memories, then it is fine. It can handle the load. But load is increasing. Then once the capacity has reached the maximum, then it is going to get failure, right? The servers will get crashed. So to handle the situations, if the CPU load is increasing or memories are increasing, then we need to plan it alternative. Okay, add that one more virtual machine with the same replica. That is important. So whatever the virtual machine with application and service we have, same replica you need to have it one more adding to this group, and this has to be registered to this load balancers, and the load balancer has to handle that routing to that the request to the third instance also automatically. It should be done automatically, not manually. So load, if it is increasing, adding that the more capacity of the resources. Our load is decreasing, then additional third one which has been launched, you can terminate it. Then keep it as a normal load, normal resources. So how to handle that mechanism? That is scalability, we'll call it. And another important feature in the production environment, update. Suppose now that application version V1 is running that, let's assume that. But a developer, they have released the V2, next version release. But without giving any impact to the end users who are accessing that, how do we update that application V1 to V2 version without having any downtime? Yeah, I'll come back to that. So updating the V1 to that V2 version without having any downtime. How do you do that? So that is a rolling update mechanisms. Or whenever you are doing that update, something is wrong. How do you do that? The rollback of the application. So that is rolling update and rollback. That is another important feature which we need to think it whenever we are designing the production. Yeah, all these points that should be considered. Yeah, we are going to talk about all these solutions once we start the cloud. So there's the infra level, how do you get it all these solutions? And the platform level, that is application, whenever we are working with that. Container based applications, how do we get it these solutions? That is the next journey. Yeah, but a load balancer's reliability, how do you get it is? Yeah, this is the active and passive approach. So we don't manage it two or two or more load balancers at the same time. So one will be active and another will be passive. So even, I mean, this is, if it is on premises, we need to, I mean, we have the separate resources who are managing about it, these load balancers. team, separate team. But if you move into the cloud providers, that is AWS and Azure team, they are managing the back end about these load balancers. You don't need to struggle that. So you don't need to, so just define what you need it. So backend, who is managing this one is this load balancers, that is by the cloud provider itself. But if it is on premises, as that big IP's point of view or Cisco tools point of view, we need to find that that particular administrator who can manage these load balancers. That is not about our role.
One doubt, sir. Actually, so if we are admin of the AWS, so if we are configuring a new setup, so this load balancer, defining load balancer, do we need to take care or?
Yes, that is we need to take care of it.
Okay.
So all these components, whatever I am talking about it, networks, firewalls, public networks, private networks, load balancers, proxy services, middleware components, even the database, we need to manage it. That is the advantage of the cloud engineer. Why they are looking at the cloud engineer with multiple skill set? Multi-skill set now. So before, if I'm the middleware, I know only this area. That's all. But you don't need to worry about the load balancers and you don't need to worry about the database. That's why the separate teams are there. And networks point of view, separate team is available. So who are managing and who are managing the DNS separate team. So we don't need to. But now, if you are going to learn that a cloud engineer is nothing but if you are learning the AWS. Within the AWS, how do you configure the DNS? DNS to the load balancer to these middleware services to the databases. So all these resources with the public network, a private network, which we should know it. That is, we are going to learn it. Don't worry about it. So we are going to see this practically all these points. Is it clear?
Yes, sir.
Yeah, as a DevOps engineer, which we should know it. Whatever I'm talking that this is today's concept is important. Reliability is how to configure, scalability is how to define it, rolling update, rollbacks, how to manage it. But whenever we are talking about it, this rollback or rolling update, we have the infra level management and as well as application level management. Suppose if I talk it, my server capacity is 16 GB. And I have these two systems with the 16 GB. But there is a requirement changing the 16 GB to the 32 GB of the RAM. I mean, this is also update, but that is update is at infra level. But how do you manage it about that infra level changes without having any downtime? That is one scenario, infra level. Next point is application. Okay, developer, they have given that current version is V5 and they have given the V6 version. But how do you update that V5 with the V6? That is also the update. But this is the application level update. Infra level changes or platform level. If you just talk it, suppose Tomcat server, which is having that version, current version is 9.x, but client is asking us moving to that 10.x, the Tomcat server version. That is also update, but that is a platform level update. So infra level rolling updates, rollbacks, or platform level rolling update, rollbacks, or application level rolling update or rollbacks. Yeah, with those managements, with the reliability, failover, scalability, securities. So all these points we are going to look into. That's when we are going to discuss the cloud. Yeah, is it clear about these points? So get that all these keywords, important keywords, whatever I'm talking is. Yeah, the load balancers keyword, proxy keyword I have used, private networks, public networks, virtual machine, databases, cluster, DNS name, load balancer, firewalls at networking level, firewalls at resource level. Before entering into the database, firewall has to be executed. Before entering into the virtual machine, firewall has to be executed. But before that, before entering into this app server networks, yes, firewall has to be executed. Yeah, there are the securities. So how you are protecting about your application is also important. So just not launching that application. So are you clear about this point? So finally, we will be having that database listeners or database endpoints, application server endpoints, proxy service related endpoints, and a main entry point. This is the entry point for the user to enter into that or access that application. But this entry point is going to route to that, the database, load balancer to the proxy URLs. But proxy URL is optional. So that is on the basis of that application requirement. Any session cookie is required, or static data is required, or if you would like to abstract it app layer from the load balancers, that is a restriction. Then this layer is optional. This layer is optional. But most of the application they prefer that. But some applications, some environments, yes, load balance to app to the database. Or some other application load balancer to the proxy layer to that app layer to the database. But on the base of the layers, these URLs required to understand that. Are you clear at this point?
Yeah. Sir, can you go with the previous slide? Actually, I have a doubt on that.
Yeah, please.
Usually, for example, you said that plugins, that is proxies and application and database. Usually, I'm not talking about cloud one. I'm generally, if you are in the DC center, that means I have my own data center.
Yes.
Will I use all these proxy apps and rack all these in the same subnet, and I'll go with the load balancer is the external one, like another. Can we set up that load balancer is a public?
Yeah.
All these we can configure as within our data center as a private, but under the same subnet. So
yes, we can do that.
Okay, so what is the flexibility? For example, what is the difference? For example, my data center, I have it. I already set up entire firewall rules for entire data center level. If I go with segregate again under the subcategory within the data center, you need additional firewall rules. You need to all these will additional burdens, right?
Correct. Additional burden, yes, definitely. But that's if you are expecting that the more security. Suppose as you were talking about it, load balancer is in the public, and the remaining all the three layers in the single subnet.
Okay.
Where one subnet level you can define the firewall, you are saying about it, and public to that. Before moving to this my private, you are going to define the rules here. Is it that right? You are saying that.
Correct. Yeah.
Yeah, if you define this, that is one level only you have defined the security group. Because in case the hacker is able to hack about this layer, then he is able to access all these components.
Okay.
But if you split into that more different networks, so advantage what you have, suppose if that hackers hacked about your load balancer and he's able to understand the backend endpoint URLs, and through that he is accessing this layer. But this layer Yeah, whenever he's asking about it, I mean, so this layer, even if he has hacked also, we don't have the importance of the data. So,
Correct.
so there's a proxy just to contain some static content, which you can replace within a minutes. It doesn't take that the time for it. That is a replacing in case it is a crash or something. So you can just replace it within the fraction of time. But app layers and database layers is not like that.
Correct.
So actual application, the important, the processing mechanism, everything we have in the app layer. And before, I mean, another important layer is the database layer. And these two things, so that is as a high priority point of view, we define this in the separate the network zones, and which will be the protected. Even that more layers, yes, definitely that is required. Okay, the first data center level, if we define it also, yes, before entering into the more subnets level, more resource level, on the basis of the resource, the importance of that security, then you can define that separate subnets. So that is as a security constraint point of view. You can suppose if I may have the development environment or testing environment, I don't need that multiple networks, simple one network, and where I can keep the databases and the middleware and the proxy layers, everything in the single network.
Yeah.
But if you move into the production, so where the hackers, so unauthenticated users are going to access it. But if you are expecting that the high security about the data, then you need to plan it more subnets. Even that more layers, if you are defining the firewalls also, yes, they prefer that. The dividing into the different subnets, and especially into the private networks, we'll move into that.
Okay. Yeah, in public also, if you, for example, Facebook, you enter your own username and credential. Sometimes people, for example, in bank environment, they captured that cookies by end user client information, right?
Yes.
Who is accessed. So while they log in their data, their logins through by load balancer, for example, they logged in and the cookies, the load balancer will take that into the next level of that proxy, right? How that proxy and load balancer will communicate it, that end user IP or load balancer IP to that proxy IP.
That is, a proxy is going to know that only load balance IP. It doesn't know that end user IP.
Oh, in those cases, they just they capture that only.
Yes. Through the headers, they capture that the client IPs, but directly the client IPs won't be communicated to the proxy layers.
Oh, okay.
But if it is the proxy is required to track that from which IP address that is accessing, or if you like to show that's in the application about that IP addresses, that is received through the headers, request headers. So with the request headers, it can be received that.
Got it. Thank you.
Yeah. And we have that session stickiness options also, which we can configure. So that is a cloud options. I'll show that how it can be handled. That same request routing to that same servers. So that is to reduce the latencies. I'll come back to some kind of the problem statement solutions in the cloud. How do we give it? But on premises, if we talk it, yes, we don't get that much scope on each and every layer. But if you're if you're going to get the chance of the cloud, yes, you should know all these layers. That is a mandatory. Even the networking level firewalls and databases, how to configure it. Even the database management, there is no separate database administrator, not required in the cloud. So AWS, you are going to say this is nothing, but you should know how to plan it, the backups, and how to manage it about the restoring concepts. And you should know that like the volumes management and volumes backups. And you should know that networkings and networks management. And you should know that the load balancers management. And you should know that even that Route 53, that is DNS configuration also. But anyway, we have all these solutions. We'll come back one by one. But this is the objective. Keep this in the mind. whenever we are going to, why we discuss the networks and with the subnets. Yes. So as a number of servers point of view, so networks, whenever we are going to learn that. Yes, the CADR, what is the overall number of the devices that is required for that application, that is divided into the multiple subnets. See, so simple. Okay, so whenever I talk it in the VPC or all that, so I'll talk it this concepts. But anyway, just to keep this all these minds, the CADR, how that is going to help in that. Is it clear at this point? If you are clear, say this the clear in the chart window, everyone, please quickly. Then we'll go ahead to the next one. Yeah, thank you. Thank you. Yeah, thank you. Pavani, Usha, Srinivas, Ajay. Okay, cool. Thank you. Thank you all. So now let's move into that. Yeah, I see there's some message at the last. What is that? Yeah, definitely first time if you're going to hear all these little bit confused, yes, you need to have it 2 or 3 times revision of it, especially non-computers. First time if you're coming to that, all these the terminologies, yes, terminologies getting into that. Yeah, that is the one time it is not possible. Yes, go ahead and review 2 or 3 times, then that would be helpful. And take the pen and paper and try to draw the diagram of it. Try to draw the diagram of this one. But in the cloud, okay, we'll come back. But this is the, at least if you know it, cloud, the last 12, 13 years, which has come into the market. But before that, also we have the solution, same on premises. But now everything that is as the managed services. Before everything we need to configure it. But now if you are moving to the cloud is nothing but everything as a ready-made. Yes, if you need the load balancer, okay, take it. Then what is the entry point and what are the endpoint? Just define it. That's all. The remaining, who is managing this load balancer availability? The load balancer is receiving that high load. Suppose, so backend to about our EC2 instances, 1 million requests are receiving is nothing but that is through this load balancer only, right? This is only one entry point. But who is managing this backend? AWS team, our cloud teams. They are helping us. But if it is on premises, yeah, we need to approach that big IP is some third-party provider. And who are the master on this load balancer? Separate resource we need to recruit it. And he should manage it about the load balancer for about our applications. But if it is the cloud, I don't need that additional resource. Just if I have the AWS account, and just I can log in it and I can so choose that which type of the load balancer is required and what is about your entry point and what about the backend endpoint. Just all. And define some algorithms and some settings, some session timeouts. That's all that is going to be managed by the database. Like that RDS also, database. If it is on-premises, separate database administrators required. If it is the MySQL, who is the master on that resource, or MS SQL or Oracle. But now, what you need it, just define it with some set of properties. And define that the backups, when do you need it? Because define that when do you want to apply that patches. Time window, just define it. Backend, who is managing that? AWS will manage it. We don't need that any database administrator. Yes, that is required. But managing these database instances point of view, that is not required. But a designing point of view, application DDL or DML, the management, and those operation point of view, database administrator is required. But managing this regular activities point of view, not require the separate database administrator. Even that, like here, virtual machines, the virtual machines management with auto scaling groups or with Yeah, the load balancers integration, and with the networks, defining that public networks, private networks, where do you want to launch it? Yeah, all those anyway, we'll come back to that, but just focus on the terminology and understand the flow of execution. Once this user is requested, yes, how the request and response is going to have it. Is it clear this point? Okay, cool. The next point. Yeah, already we discussed some networking concepts, right? About that, especially CADR concepts you are understanding. Subnet mask, and as well as yeah, the normal, the old architecture of that classes, class A, class B, class C, and the latest architecture point of view, the CADR notations. That is a classless, we'll say that. So total two types. One is class-based, classless. That is CADR, classless inter-domain, the routing rules. And we are understanding some commands how to view that IP addresses of the system. So what is the command for it? List of all the IP addresses, how do we see that? Yeah, that is the if config. That is for that like Linux operating system, and IP config, that is for the Windows operating system. And we were talking this one more command. How do we view that list of all the ports which are listening on the system? How do we verify this list of all the ports which are listening on the system? So whenever we are talking about the service level, we were observing that. That's command. Yeah, that is netstat-nltp command, netstat command. Yeah, so if you just quickly go for this, if config, so to view that list of all the network interfaces, and we are understanding the IP addresses and identifying that subnet mask and broadcasting channel. And do we have any errors while receiving that packets or transmitting that the packets? Yeah, errors identifying. So this is one command which we are trying to understand. And understanding the network interfaces, Ethernet 0 or Ethernet 1 or loopback adapter. So every system is going to have the by default loopback adapter, which is having that. This is the IP address 127.0.0.1. And another concept, let me just conclude it that. So already I hope so this command also show up with that. So what is the purpose of the ping command?
Internet availability checking.
Yeah, that is instead of saying that's internet, site is reachable or not, or remote, the system is reachable or not, to check it, that is going to help. Not only just internet, even that within the networks, yes, particular one system to another system, the networks are allowed or not. That means the target or the remote system is reachable or not, to check it. Our site is reachable or not. Yes, the ping command is helping. But ping level, if you just observe that, suppose if I give that the google.com, so it is keep on pinging that, right? So that means it is sending that the packets and it is receiving that the packets and time, how much time it has been taken. It is showing us the time. So it is the pinging the data. The Google is reachable and getting the response back. This is the time which is taking that in the milliseconds. So we are good. But if you see there's here this command, ping command, it is keep on pinging that. Keep on pinging that. But if you are writing that, suppose manager is asking, or client is asking that, boss, write one shell script, whether about our site is reachable or not, we need to keep on checking that. In case site is not reachable, that means if the site is down, we need to send the email notification to about our team. So this is kind of some automation requirement. So how do you implement the shell script? That is the next we are going to talk about. But in the shell script, I need to use the ping command and I need to give that site URL. But it is keep on pinging, right? It is not returning back. So here we are using either Control C or Control Z option. If you Control Z is also not working, Control C. Okay. Okay, Control Z. It has been stopped the process. That means until that explicitly stopping, that process is keep on pinging that. The ping command, keep on pinging that. But whenever you are doing that automation scripts, we don't want to ping it like the continuously. So I would like to pass it some 5 packets, and 5 packets have been successfully transmitted and received a response. Then site is reachable. So I need to specify particular number of packets. That means count. How I can define that the count number of packets is. This is especially whenever you are writing the shell scripts. This option is going to help you in the ping command. That is -c. That is a count. And if I say that, okay, I need to check it with the 2 packets also I can check it, or 4 packets also I can check it. So just define that how many number of packets do you want to transmit it to check that whether the site is reachable or not. Now we have defined that the count as a 4. That means 4 packets that have been transmitted and 4 packets that have been received. So I'm good. So that means I can understand it. Google.com site is reachable. So this is one more important option. What do you have to say is in the ping command, whenever we are going to write it automation scripts, in the scripts, if you would like to check that the remote system is reachable or site is reachable or not, we don't directly define the ping and site or IP address. So we need to use that count also. This is a very important argument in the ping command. Now I'm able to ping to this google.com, but how do I check it this one? How do I get the status of this one? Ping is okay, whenever I'm observing that output, the manually, okay, whenever I see this 4 packets transmitted, 4 received, and 0% packet loss. 0% packet loss is nothing but all the communications from this site to the google.com is okay. But how do we know that whenever I'm writing the script doesn't know this, right? This output. So whenever we are verifying with the ping command output, yes, we can understand it. It is successful or a failure. Suppose if I run it something google1.com. So it says that the google1.com is not known. That means now this site is unreachable. Now this site is reachable. How do I know that? In the automation approach. ping google.com grep time. No. So simple approach, what do you have to say?
Ping with the IP address. Ping with the IP address. You want to use the text file one.
Yeah, whether it is IP address or site URL, you can give it. It doesn't matter that. But here, how do we know that in the script approach, where the ping is successfully executed or not? Okay, -t option. So even okay, -t, if you use it, what is that option -t? Time to live. So this is just giving that time to live option. No, this is also not going to help in that. Simple, what do we do this is, once that command has been executed, okay, we run this command, and after this command, the previous or lastly executed command, is it successful or not? We can get the status by using that $question. Echo, I'm just printing that. But what is that? How to catch that the previous command status is $? If I use it, what it is written? It is written 0. The 0 is nothing but that is successfully executed. Suppose if I run it Google with google1.com, okay, it is saying that whenever manually we are verifying it, we can understand it. Okay, that is not reachable. But through the scripting, how do you know that is? If I take this $question, what it is written here? Non-zero. So if the 0 returns, the site is reachable. Or if it is the non-zero returns, the site is down. Simple. We use that condition. How to implement the condition? Then whenever we are learning that shell scripting, this will come back. But before moving to the automation, yes, there are some points which we should understand it. Yes, the ping, especially this, the ping important option is -c use it. If you don't use it, it is keep on trying to ping it. It never comes back. But if you like to control it, yes, you can use the -c option. If the site is reachable, yes, it is going to keep on trying to communicate with that. And we can control with the count. But after has been executed, whether it is successfully executed or not, we can use it $question, which is going to helping that to know the status of the previous command. This can be applied to that any command, but yes, the ping option point of view, ping, the site reachable or not, you need to write it some automation aspect. Yeah, during that case, the ping we use it, but site is reachable or not, how to check it is $question. Is it clear these points? The one more important attribute, that is $question. Yeah, ping with that option, and then $question. That is to know the status of the previous command. This is not only for that. Suppose if I'm running that ls command, ls-l. Now this command is successful or failure? What do you understand this? ls-l command I have executed. This command, is it successfully executed or is it a failed?
Successful.
Yeah, that is successful. But suppose if I run this one, is it successful or the failure?
Failure one is showing like 2.
So that whatever I'm going to try to list it, no file, that no file is not available, right? So no such file or directory is saying that. But how do we know that programming critically that command is successful or the failure? Yes, important, very important special character, that is $? Now, if it returns that's non-zero, that is a failure. Suppose if I run it ls-l, and if I try to execute this question mark, that returns a 0. It returns 0 is nothing but that is above command is successful. Is it clear about that? How do you know that the status of the commands, the previous executed commands, or last command, the command which has been executed, that is successful or the failure? How do you know that is? Important argument, $? Yeah, sometimes we need to write it automation scripts, the sites, the availability, or the particular, the IP addresses, the reachability. Yes, whenever you have this kind of activities, yes, the ping command with the -c option, which you can use it, and use it $? To catch the status of those, the ping command. Yes, ping if config and netstat -nltp to know the list of all the ports which are listening. Yes, in the system, which are all the services are running that? Can you list it that? By referring these port numbers, which are all the services are running on the system? Which are all the services are running on the system by referring these ports? Tomcat, no, that's not the Tomcat. No. Now I just now I just run it netstat command and some ports listening here. You see this, some ports listening here. These ports are belong to the which services. I'm just asking that, that's point. $80 is belong to the which service?
Apache Tomcat.
No, this is not Apache Tomcat, Apache HTTP server.
This is what IPv6.
Means at times we may have some reserved ports, no sir.
Yeah, yes. 80 for the web server, and what is the default server? That's we have this is Apache server. So we were installing that Apache service. What of the 22? Which service? Yeah, that is SSH service. Some standard ports which we have for some services. Like what are those services if you just talk it? HTTP, what is the default port is 80. Whenever you see this 80, simple by default we can understand that is for HTTP protocol. And SSH, what is the port? 22. If you see this 22 is listening on the system, then we can understand that is for SSH. And what about the FTP?
21.
Yeah, files uploading or downloading. If you see this kind of activity, background, what is the protocol it is using is that is the FTP protocol. Now, what is the default port of that FTP
21.
is 21. Suppose you are sending the mail. Suppose Gmail. Yes, we are using the Gmail and we are sending the mails. So what is the protocol that is going to use it is SMTP. So simple mail transfer protocol. But what is the port behind for it? What is that SMTP port? That is 25. And another thing like which I have to say is HTTP we are using. HTTP is a non-secure. But if the web server is defined with the secure protocol, that's we say that HTTPS, that is securing the data between the client and server. But what is the default port of the HTTPS server? These are all required to remember that. Some default services and default ports. As HTTP, whenever we see that is a 80. SH, the 22 whenever we hear, just remember that SH protocol. 21 FTP, 25 SMTP. What about the HTTPS?
443.
That is 443. And a Tomcat, what is the default port?
8080.
8080.
Yes, 8080. And MySQL database. MySQL default port is 3306 default port. And DNS service, what is the default port?
110.
DNS, domain name service, what is the default port? 53. Yeah, so there are some ports, the standard ports which are defined for these services. So DNS, if you are working that, you are going to work with the 53 port. MySQL, you are working is nothing but a default port is 3306. Tomcat, HTTPS, the SMTP services, or FTP service, or SH service, or HTTP service. Yeah, there are some standard ports which are defined. Suppose whenever we are connecting to the system, Vagrant SH, I'm not giving that any port number. That is a 22, I'm not giving that. That means if I use it SH mechanism, by default, it is going to use it 22 ports. Or whenever I'm using that HTTP service accessing the browser, I'm directly giving that. Suppose if we just observe that curl localhost. And if I use that the protocol HTTP. If I don't specify that any port is nothing but, now default, what is the port it is going to take it? 80 port. I didn't specify that explicitly in the URL. 80, I didn't specify that. Even if I specify it, or if I don't specify it, output is the same. Because HTTP default, it is going to use the port 80. Yeah, if you have defined the default ports, then you don't need to specify explicitly the port number whenever you are connecting to the system or accessing the system. Is it clear about that? Some default ports of the services. Yeah, remember at least these points, that's more enough. But on the basis of like a Jenkins, whenever we are going to talk at Jenkins is going to add one default port, that is on the basis of the services. But common services are the common ports. Yes, they're all the common things which we should remember it. But like that IMAP we have, or LDAP protocols we have. So that is on the basis of the protocol, that protocol related different, the default port. Whenever we hear that a default port is nothing but just to use a protocol, then you don't need to define explicitly the port number. That's concept, if you got it, that is more enough. That means here, whenever I'm running the HTTP protocol, I didn't specify that 80 port, but it is connected to my web server. How it is connected to my web server automatically here? Yes, I use that HTTP protocol. HTTP default port is 80. On the system 80 is running. That means my request is submitted now to this 80 service. Or if I'm using that SSH with some IP address 192.168.33.11, some IP address. If I don't specify that any port here is nothing but What is the default port it is going to use it? 22 port. Yeah, that host is not reachable anyway. That is a different story. But it is trying to connect it. You see that the port number 22. I didn't specify anywhere about that 22. I just used the SH and with the IP address. That means in this IP address, it is trying to access the 22 servers. Is it clear about this? The default ports advantage? See, in the google.com or technologies.com, we are not entering that the port number. Only domain name we are given that. That means on the base of the protocol which you are using, automatically it is mapping to the backend port numbers. So if I use it HTTP, it is routing to that load balancer which is running on the port 80. If I use it HTTPS protocol, it is routing to that server IP address which is on the port number 443. Yeah, so that is understanding that default services and the default ports. And understanding that how do we verify that sites are reachable or not? Through manually or through programmatically. Programmatically, how do you know that the status of the commands? That is $? Is very, very important. In interviews, they will ask you that. And if you are implementing the shell scripts next, that we use it the mostly this option to decide that the site is reachable or not, whether the particular system is reachable or not. Yeah, those kind of evaluations, if you're expecting that on the command, that command status is how to get it is $? Yeah, there are some points, some more points on the networking side, and we have the host name some points, and we'll talk it tomorrow, and then we'll continue that users management section. Yeah, so that's all from my side for today. Understanding the high-level architecture, important terminologies, just note it. And go ahead and review this one more time. If you are not having that's the clarity, yes, refer that. And refer some commands for here as well. So understanding about nested command usage. And if you see the any ports, these ports are listening. Listening is nothing but the services are up and running. So this is a very, very important command. Yeah, so that's all from my side. We'll log in tomorrow and we'll continue some host names related understanding on this. And then we'll see that users management section. Yeah, any queries, questions, please? Thank you. Yeah, welcome. Thank you. Yeah, good. So that's all from my side for today. So I'm going to log off for today. We'll meet tomorrow.